underneath Yellowstone that if it erupts in a maximum eruption called Category 8, it could literally tear the guts out of the United States of America.
Yellowstone has always been a hotbed of excitement, drawing in hordes of tourists with its jaw-dropping attractions, but now, there's an extra reason to be careful while you explore. World-renowned physicist Michio Kaku just dropped a major announcement. Yellowstone is finally erupting in 2023, and it might just destroy the entire thing. This restless Yellowstone caldera is truly living, breathing. Every once in a while, it burps. Join us as we dig deeper into Michio Kaku's announcement, and what it means for the future of the national park, and the Earth as a whole. We can't start a video about Yellowstone without mentioning the Grand Canyon. Over time, the mighty Yellowstone River has sculpted this magnificent canyon, stretching an impressive 20 miles in length, and plunging to depths of 1,200 feet. The lower falls steal the show as the river cascades down a staggering 308 feet. That's about twice the height of Niagara Falls. The impact when it strikes the canyon floor creates a mesmerizing sight, with foam and mist shooting hundreds of feet into the air. The rocks at the base of the falls are constantly wet as the mist comes down, so they have vibrant green moss on them throughout the year. As the river races along, the foam subsides, revealing its true color, crystal clear. It's the presence of algae and moss that gives the water a remarkable green hue. All of this combines to create a visual that you just can't find anywhere else. We also can't forget about the Mammoth Hot Springs. Here, a unique combination of heat, water, minerals, and limestone has given rise to this fascinating geological phenomenon. As the hot water rises from deep within the earth, it dissolves calcium carbonate from the limestone layers underground. This dissolved calcium carbonate, known as travertine, is carried to the surface by the ascending hot springs. That brings us to another popular gem within Yellowstone National Park, the Upper Geyser Basin. This place is like the jackpot of geothermal wonders, boasting the highest concentration of geothermal features in the entire park. And right at the heart of it all is the legendary Old Faithful Geyser. If you want to witness the spectacle of a geyser eruption, this is definitely the place to be. The park even has the power to predict the eruptions of not just one, but 5 large geysers in this incredible basin. But here's the twist, all of these geothermal features have a common element, a fiery and scorching force that you definitely don't want to mess with: volcanoes. Yellowstone is known for its close connection to these powerful beasts of nature. Their effects can be seen and felt throughout the park, adding to its unique charm. But guess what? There's something new brewing, and it's terrifying. In the span of a mere 24 hours, the park experienced something quite unnerving. A colossal crack, a whopping 100 feet wide, appeared out of nowhere in Teton, and it's got the park authorities on high alert. They swiftly closed off a large section of the park to conduct urgent investigations, determined to unravel the mystery and understand what this means for the surrounding landscape. Teton is no stranger to volcanoes. That's because of 4 geologic factors: tough hard rocks in the core, vertical uplift, the age of the mountain, and dynamic forces of destruction. Many other mountains in Wyoming have equally hard rocks in their cores, and an equal amount of vertical uplift. But they rose 50 to 60 million years ago and have since been eroded. The Tetons, on the other hand, are Wyoming's youngest range, dating back less than 10 million years, and that's why they're still around and haven't been eroded. But what makes the Teton so special, apart from their age? The majority of the Teton Range's rocks are among the hardest, toughest, and least porous known in the entire world. As a result, they are resistant to mechanical disintegration caused by temperature changes, ice, and water. They're primarily composed of minerals that undergo very little chemical decay in the cold climate of the Tetons, and the absence of weak layers prevents the tough rock masses from collapsing under their own weight. So they're able to stand their ground for a lot longer than an average mountain range. All of these conditions favor the preservation of steep walls and high rock pinnacles. But that doesn't mean they're totally unbreakable. They do degrade over time, and great piles of broken rock or talus cover the slopes of all the higher peaks. So it's obvious that even the strongest of rocks here. But that's not the only thing. A wide range of daily and annual temperatures causes minute contraction and expansion of rock particles. Stress and strain are produced by repeated volume changes. So, although the Teton's rocks are extremely dense, they eventually give up because of the temperature, and cracks form. Some cracks are on the smaller side, but others make their presence known. The fissure was discovered in the Teton area, where the rocks are tough and hard, but even they can't withstand the forces of nature forever. Water that seeps in along the surface of weakness freezes and expands, prying a slab of rock away from the mountain wall, one tiny step at a time. This process, known as frost wedging, eventually causes the slab to tip and fall. And when that happens, it's disaster time. It's a never-ending struggle between two opposing forces, the rock's extreme toughness, and the presence of forces that move all rock debris away from the mountains and away from the lower slopes. The result is a constantly changing landscape that is both beautiful and dangerous. When a slab of rock breaks away from the mountain wall, it can fall and roll hundreds or thousands of feet, breaking into pieces as it encounters obstacles. All of these fragments make their way down to the valley floor or slope, where they briefly rest before gravity takes over and moves them even further. This isn't a stationary process either. If the rock debris is mixed with snow or saturated with water, it can flow slowly like a glacier. In fact, there's one nearly a mile long in the valley north of Eagle's Rest Peak. Snow avalanches also play a role in gravitational transport, carrying loose rocks and debris down the mountainsides to the tailless piles below. These avalanches leave visible scars down the slopes, exposing new rock surfaces to water and frost attacks. And let's not forget about the power of running water. It's another effective agent for transporting rock debris, aided by the devastating floods that can happen in the spring. All of this brings us back to the crack in the Teton area. Experts have discovered expanding cracks in the rock, and they're closely monitoring it for any signs of movement. This is especially important because Yellowstone is currently recharging. That means its magma chambers are filling up with molten rock from deep beneath the Earth's crust. Once these magma chambers are filled to the brim, the landform could erupt at any time, whether it's a matter of months or even millennia after a magma recharge. The eruption happens when those chambers rupture, releasing an astounding amount of magma all the way into the atmosphere. Here, we're talking up to 240 cubic miles of explosive volcanic rock called rhyolite. This type of rock is so powerful that it can easily break through the Earth's crust during an eruption, and holds the key to the volcano's destructive power. Researchers studying the area have been focusing their attention on the plume of magma that's heating the rhyolite from below. They're all about figuring out just how much magma is recharging the volcano each year. To do this, they injected a stable radioactive isotope called deuterium into several hot springs in Yellowstone National Park. Don't worry, even though this sounds crazy, it's totally safe for the environment, and it's even been given the green light by the park officials. Now, these hot springs are connected to a network of hydrothermal vents that play a crucial role in the Yellowstone volcanic system. The researchers calculated the amount of water and heat flowing out of the springs by measuring the temperature and tracking how long it took for the deuterium to return to normal background radiation levels. This is a great way to test things out without having to deal with actual magma. Turns out, previous studies underestimated the amount of water flowing through the springs and the amount of heat leaving them. There's a lot of it, and it's turned the volcano that was thought to be dormant into a ticking time bomb. Scientists say that it's only a matter of time before the massive supervolcano wakes up and unleashes a Category 8 eruption that could take the entire country with it. That's possible because Yellowstone doesn't just have a single dangerous volcano. We're talking about the Yellowstone hotspot. The Yellowstone hotspot is a geologic phenomenon that has played a pivotal role in shaping the landscape of the northwestern United States over millions of years. It's a stationary area of intense volcanic activity beneath the Earth's crust, responsible for the creation of the Yellowstone caldera and the geothermal wonders found within Yellowstone National Park. The hotspot is believed to have originated from a mantle plume, a vertical column of exceptionally hot rock rising from deep within the Earth. As the North American tectonic plate slowly moves across the hotspot, it creates a trail of volcanic activity. Over time, the movement of the plate has left a trail of extinct volcanic centers extending from Oregon, through Idaho and into Wyoming, with Yellowstone being the most prominent and recent manifestation. Yellowstone's volcanic activity is a direct result of the hotspot. The hotspot fuels the magma chamber beneath the park, providing the energy and material for volcanic eruptions and geothermal features. This subterranean heat source gives rise to the iconic geysers, hot springs, fumaroles, and mud pots that draw millions of visitors to the park each year. The hotspot's influence extends far beyond Yellowstone National Park. It has left a trail of volcanic features and past eruptions throughout the region. For instance, the Snake River Plain in southern Idaho is a product of the hotspot's volcanic activity. It is characterized by a series of lava flows and volcanic fields that were produced as the North American plate moved across the hotspot. The Craters of the Moon National Monument and Preserve is a testament to this volcanic legacy. Although the hotspot has been active for millions of years, its intensity has varied over time. There have been periods of heightened volcanic activity marked by massive super-eruptions, such as those that formed the Yellowstone caldera. These cataclysmic events occur on a timescale of hundreds of thousands of years, and are separated by much longer periods of relative quiescence. The Yellowstone hotspot has been something that scientists and geologists have known for decades. It provides a unique window into the processes occurring deep within the Earth's mantle, and offers valuable insights into the dynamics of mantle plumes and plate tectonics. Ongoing research and monitoring efforts help unravel the mysteries surrounding the hotspot, and contribute to our understanding of Earth's geologic history. While the hotspot continues to fuel geothermal activity, and shape the landscape, including the potential for future volcanic eruptions, the future we're talking about here might be close. In the past few months, we've witnessed some alarming activity in the park. The ground has been rising, and a whopping 465-mile-long molten rock is on the move directly under Yellowstone. Adding fuel to the fire, the major geysers have been more active than ever before, leaving many wondering whether the signs are pointing toward an inevitable eruption. Imagine if Mount St. Helens eruption in 1980 was just a tiny sneeze compared to the Yellowstone super-eruption. We're talking about a magnitude of 8 or higher on the Volcano Explosivity Index, ejecting at least 1,000 cubic kilometers of material, enough to bury the entire state of Texas 5 feet under. And this isn't just a hypothetical situation. This supervolcano has erupted 3 times before: 2.1 million, 1.3 million, and 664,000 years ago. The last eruption created a 34-mile by 50-mile depression called the Yellowstone caldera. Yellowstone isn't the only supervolcano on Earth. Geologists have discovered evidence of at least 47 super-eruptions throughout our planet's history, with the most recent occurring 26,000 years ago in New Zealand. And it's going to take a lot to make sure it doesn't happen to Yellowstone. NASA has proposed drilling up to 6 miles into the supervolcano, and pumping in high-pressure water to cool it down. They believe that using heat as a resource to build a geothermal power plant could offset the cost of the mission. However, drilling into the magma chamber's top would be extremely risky, with the potential to backfire and cause the very super eruption they are attempting to prevent. Furthermore, even if the drilling plan were to work, it would take tens of thousands of years to completely cool the supervolcano, and there's still no guarantee it will be successful for hundreds, if not thousands, of years. So if NASA doesn't succeed in preventing a Yellowstone eruption, we're in for a disaster. Scientists, armed with historical ash deposits and advanced modeling, have painted a grim picture. They predict that a super eruption would blanket the northern Rockies with a whopping 3 feet of ash. Can you imagine the chaos that would ensue in Wyoming, Idaho, Colorado, Montana, and Utah? Meanwhile, the Midwest would receive a few inches of ash, and both coasts would fare slightly better with even less ash fall. But trust me, even a few inches of this volcanic menace can wreak havoc. It has the potential to be a silent killer. It can smother plants, animals, and unfortunately people. Buildings would crumble under their weight, roadways would be clogged, and respiratory problems would skyrocket. Just a few inches of ashfall could disrupt power lines, short out transformers, and bring North America's air travel to a grinding halt. Imagine being stranded without a flight for who knows how long. When it comes to the global climate, the consequences of a large volcanic eruption like the one that could potentially occur at Yellowstone are truly remarkable. These explosive events release massive amounts of sulfur aerosols into the atmosphere, forming a protective shield that has a cooling effect on the planet. Now, you might be wondering how these sulfur aerosols work. Well, when they reach the upper layers of the atmosphere, they scatter and reflect sunlight back into space. This leads to a reduction in the amount of solar radiation reaching the Earth's surface, resulting in a cooling effect. It's like nature's own built-in air conditioning system, but on a planetary scale, one that has no thermostat, so everything would just get colder and colder. The impact of these volcanic aerosols can be quite substantial. Let's take the eruption of Mount Pinatubo in the Philippines as an example. When it erupted in 1991, it released an enormous quantity of sulfur dioxide into the atmosphere. This caused a significant cooling effect on a global scale. In fact, the planet's average temperature dropped by about 1 degree Celsius for several years following the eruption. This might not sound like much, but when we're talking about the delicate balance of the Earth's climate, even a small change can have far-reaching consequences. Another notable case is the eruption of Mount Tambora in 1815, located in present-day Indonesia. This cataclysmic event was one of the most powerful volcanic eruptions in recorded history. The eruption spewed a tremendous amount of volcanic ash and gases into the atmosphere, including an abundance of sulfur aerosols. This led to a substantial cooling effect on a global scale. The following year, 1816, became known as the year without a summer in many parts of the world. Crops failed, leading to widespread food shortages and famines in various regions. So if Yellowstone were to experience a super eruption, It's not just the immediate vicinity that would bear the brunt of the impact. The release of sulfur aerosols into the atmosphere would have far-reaching consequences, potentially affecting weather patterns and agricultural productivity worldwide. It could disrupt ecosystems, harm food production, and impact human livelihoods on a global scale. While the cooling effect from volcanic aerosols is temporary due to their relatively short lifespan in the atmosphere, it can still have profound effects on the climate. According to Dr. Michio Kaku, a renowned physicist, Yellowstone is going to erupt in 2023. He's been predicting the eruption for over a decade now, but at the same time, he thinks that we shouldn't worry too much as we will get advanced warnings before the eruption. He believes that we will have several weeks to evacuate before any such unlikely event takes place. But what if we have been ignoring the warnings that we have already been getting? For instance, in 2018, the Steamboat Geyser, the world's tallest active geyser, erupted a record-breaking 32 times, more than it had in any other year in all of history. Other geysers have also been behaving strangely, like the Excelsior Geyser, which had been quiet since 1957, suddenly erupted spectacularly a few months back, spewing out garbage from the 1930s. Adding to the chaos, the ground beneath Yellowstone has been steadily rising for the past few years, and the area has been rocked by over 121 earthquakes in December alone. In the North Geyser Basin, GPS data showed that the ground had risen by about 2 centimeters in 2018, and it hasn't stopped ever since. All these signs indicate that our planet is becoming increasingly unstable, and it's only a matter of time before we witness unprecedented natural disasters. Unfortunately, the experts keep reassuring the public that everything is going to be all right, but the shaking of our planet is getting worse with each passing year, and multitudes of people are going to die in these disasters. However, if scientists are to take Michio Kaku's advice, things might actually work out. That's why researchers from all over the world have come together at the Yellowstone Volcano Observatory, and they're working day and night to get ahead of the eruption. So if things start to get bad and there comes a point where we can't run from the volcano, the least we can do is minimize the disastrous effects of it. At the observatory, scientists employ a variety of tools to track the activity of the Yellowstone caldera, ranging from ground-based monitoring stations to satellite imagery. One of the most important instruments used by the team is the seismometer, which measures the tremors and vibrations that are produced by the movement of magma and other geological phenomena deep beneath the Earth's surface. Because this part is just basic, if you can track where the magma is, and how fast it's growing and moving, you can at least have an estimate of how much time it would take for everything to get to the breaking point. In addition to seismic activity, scientists keep a close eye on the temperature and chemistry of the hot springs and geysers that dot the Yellowstone landscape. As we've discussed earlier on in the video, all of the geothermal features work together to make Yellowstone the threat that it is, so keeping an eye on them is integral. Another key area of research at Yellowstone Volcano Observatory is the study of volcanic gases. Volcanoes emit a wide range of gases, including sulfur dioxide, carbon dioxide, and water vapor, which can provide valuable insights into the composition and behavior of the magma chamber beneath the Yellowstone caldera. Scientists use advanced techniques such as remote sensing and gas sampling to collect and analyze volcanic gas data from across the park, providing crucial information about the activity of the Yellowstone system. Despite the many challenges and risks associated with studying a volcano as complex and unpredictable as the Yellowstone caldera, the team remains committed to advancing our understanding of this natural wonder. In recent years, advances in technology and data analysis have allowed scientists to make significant strides in our knowledge of the Yellowstone system, including the discovery of previously unknown features, such as the shallow magma reservoir that lies just a few kilometers beneath the park's surface. Scientists work closely with federal, state, and local agencies to provide real-time monitoring and alerts in the event of increased volcanic activity, helping to ensure the safety and well-being of the millions of visitors who flock to Yellowstone National Park each year. Because if they didn't, just for one day and miss something, it could mean the difference between life and death of not just the people in the park but also the entire planet. Do you think we could make it through a Yellowstone supernova eruption? Let us know in the comments below. If you liked this video, please give it a thumbs up, and we'll see you in the next one.